So we will be recording this part of the session, and we're going to continue with the exercises where we are practicing, Kirchoff's laws. And we had already done a couple of exercises. And right now we're mostly talking about Kirchoff's current law. First law has to do with the currents that go in are equal to the ones that go out. And we're kind of looking at proportionality things here. So we've got now this circuit. I don't know if this was the third one for you guys also. Was it? Was it the third one in the order that
Professor,
you guys...
I'm still
Yes.
seeing the PowerPoint.
Oh, thank you very much, Lucia. Now, there we go. Apparently the web page stayed in the, I might have some cookies activated here or something, but it stayed in the one. It's telling me that I'm in number 3. So was this the third one for you guys? Can somebody confirm? And the notes that you had, was this the third exercise?
Let me check.
Yes.
Okay.
Okay, yes.
So let's analyze. It says 4 identical resistors. Remember, the values of the resistors are important. Not the values, but if it's the same, if it's larger, if it's smaller, those are important because of the currents. Remember that the resistor is a restriction of the opposition of flow of current. So we've got 4 resistors that are exactly of the same value. Okay, 4 resistors that are exactly of the same value. And they're connected in this array that we have here. How do the currents at the labeled locations compare? And we want to kind of know what's happening there. Okay, so what assumptions can we make here in the circuit that might be useful to know? Anybody? Anybody things that we can identify clearly here? Okay, anybody?
I'm not sure really.
Of the currents that we have here, any relationship that we can make with any of these currents that's obvious?
I said that when we did it, like the current number 4 was the like the biggest one, the one,
Okay.
because we saw the different options and we saw that would be like no.
Mm-hmm. Okay.
No, wait,
So,
no. I'll cancel that. I don't remember.
Well, we could assume that current 4, which is the current that has to do with the battery, would be the current that's going to be distributed. We could assume that. That's not necessarily incorrect, because it's this loop here is the one that has the battery. So since the battery is providing the energy, we could assume that this current is being somehow divided in the rest. So yeah. What else? Is there anything else that we see there that might be a relationship that's clear or obvious? What can we say about I2 and I3? If we look at these
They
two,
are equal.
yes, correct, JC. I2 is going through here and then it's coming over here. So if we notice, it's the same current. So we can say that I2 is equal to I3. That's a statement that is valid. Okay, from here. Okay, I2 is going to be equal to I3. Okay, that's something that's true. Okay, now that means that which one can we eliminate from these options? Then do we have 4 options? Yeah, we've got 4 options. Which one could we eliminate here by default of these 4? We could eliminate A. We know it's not going to be A. Okay. We draw this here. We know it's not going to be A. And so this is going to be the same here. We know that I2 is going to be the same as I3. Okay.
And if we assume that the 4 is the biggest one, then also C.
Okay, let's see that, JC. So if we assume that I4 is going to be the larger one, okay, then that means that we could also probably, yeah, as you mentioned, we could probably eliminate C because it says that this is larger. Now, what's gonna happen here? Let's assume that I4 let's assume that I4 is the larger current. So this current is coming over here, okay? And there's going to be a current here that's going through this resistor, and there's going to be another current going through this resistor here, okay? We haven't put a name to that current. I'm going to call it IX. And then there's also going to be a current going through this resistor, which I'm going to call IY. Would you agree? So every resistor is going to have a current, okay? So one thing that I do know because of Kirchoff's current law, I know that I2 or I3, however we want to say it, plus IX has to be equal to I4. The sum of these two that are going into this junction has to be equal to I4. And on the other hand, over here on this junction, there's also a division. So I1 plus let me just make sure I'm not confused. This is a 4, not a Y. I1 plus IY is going to be equal to I4 also. Okay. Now, of these currents that we have here, the current is going to be divided. If the two resistors are the same, then how is the current going to be divided? If the two resistors are exactly the same, how is the current going to be divided? Anybody tell me? So if again, I've got a flow and it divides two ways.
Half and half.
Half and half. It's going to be exact. They're going to be the same.
Yeah.
So really here, I2 equals I3, and this also has to equal IX. Okay. And also over here, I1 and IY also have to be the same. Because there's going to be a division of current there. Okay. Okay. So one thing that we can also eliminate, somebody said we could eliminate, for example, we can eliminate B because I4 and I1 are not going to be the same. This is not true. This is true, but this isn't true. So B can also be eliminated. Okay. So now we're left with C and D. Which one of these would be the correct one? JC said something about eliminating C, and that's correct. Why? Because we were mentioning that I4 is the largest current, and I4 is the current that's being divided. We also mentioned that I2 and I3 are the same, and it's the same as this other current here. However, I4 is being divided into two resistors that are exactly of the same value, and the same division that's happening here on the left-hand side is also happening up here. So something that we can also assume is that I2 equals I3, and it's also going to be equal to I1 because all of the resistors are the same. So the division is going to occur equally. So in this case, C does not apply, and D is the one that gives us the relationship that I4 is the largest current and I2 is equal to I3. We already established that, but since all of the resistors are the same, it's going to also be the same as I1, which is this. So the solution should be D. By the way, a question, just a question. It's going to be recorded. When I if I here in Zoom, if I open the chat, can you see the chat right now?
I don't think, no.
No.
Okay,
No.
I'm just curious if Zoom does that when it's being recorded. So it should be D. Okay, let's see what happens there. I'm going to select D, and it is correct. Okay, it says nice work. Keep going. Okay, it is correct. It just moved over there. Okay, okay, I'm going to clear this up. Let's go on to the next one. Now we've got 4 identical resistors that are connected to that battery. And they're asking us to speak about the 4 currents in each of the resistors. So we're going to have one current I1 going here, another current I2 going here, another current I4 going here, and another current I3 going here. What do we know about those currents looking at the circuit? Can somebody tell me some relationships that we see there? Remember that the resistors are the same. So can somebody tell me any relationships, clear relationships that we see there?
I don't know if the 2 and 3 are equal and 1 and 4 are equal.
Okay, yes, and let's talk about that. Let's talk about 1 and 4. So a premise here is that I1 is equal to I4. Why would I1 and I4 be equal? What's the type of connection we have with these 3 elements?
Series.
Correct, JC. So I4, the battery, and I1, the 3 of them are connected in series amongst themselves. So if they're connected in series, therefore, the current that goes through one is the same current that's going to go through the other. Okay? That's correct. What connection do we have with I2 and I3? What type of connection do we have there?
Parallel.
It's a parallel. Okay? Okay, it's a parallel. Now, if it's a parallel connection, that means that the current is going to be divided. If the 2 resistors are exactly the same, how is the current going to be divided?
Half and half.
Half and half. So that means that, like Carmina said, I2 is equal to I3. Okay? So let's see which ones here we can eliminate. I1 is larger than I2 is larger than I3 is larger than I4. Well, we know that this isn't true because they're the same. This other relationship, I4 to I2 to I3 to I1, this would also be eliminated because we see that some of them are the same. So we're left with these 2 options. Now, which of the currents would be larger? Can somebody tell me? We know that I1 is equal to I4, I2 is equal to I3, but between these 2 that we know are, have a relationship, between this one and this one, which is larger? Which do you think is larger?
I
1 and
think
4.
1 and 4, yes.
Yes.
I1 and 4. And why? Because by logic, again, the power supply is here in this loop on the left, and the power supply is providing energy. So that is going to be the current that's being provided that has to be divided. Okay, so we can assume correctly that this one is larger. Again, that's because that's the loop where we've got the power supply. And so if we look at the options that we have here, we've got an option that says I1 equals to I4, and that's larger than I2 and I3. This one says I2 and I3 is larger than I1 and I4, this one would not be correct. And so we should be left with, B. Okay, with this one. Okay, let's see if that's the case. Okay. Bling, bling. Okay, did good. That one is correct. Okay. Okay, remember, if anybody has any questions, let me know. Okay, good. Let's erase this. Let's go to the next question. Remember, these are being recorded. These are being recorded, okay? So you can review them further on. Okay. Now we've got our next one. It says for the circuit shown, the current out of the battery is 4 amps, and the current that passes through the 6 ohm resistor is 1 amp. What is the current that passes through R3? Okay. Now we have a problem that's got numerical values. So we need to apply Kirchoff's current law or node law. So we've got 4 amps going here. The power supply is providing 4 amps. And these 4 amps are going through this going through this branch. Okay. They're coming out. Let's how many nodes does this circuit have? Can somebody tell me? Can somebody tell me how many nodes this circuit has?
2.
2.
2. We've got 1 node. I'm going to call this one here node. I'm going to call this one node A. And I'm going to call this one node B. Now, we've got the current of 4 amps, and then we've got another current here that's a 1 amp current that's going through the 6 ohm resistor. And there should also be a current going through the 3 ohm resistor. Now, we don't know that current. That's the one they're asking us for. I'm going to call it IX. So if we apply Kirchoff's current law in node A, can somebody tell me what currents are going into node A? What are the currents that are going into node A?
The green one.
Give me values because there's two greens here.
Oh, the 4 amperes.
Okay, so what's going into node A is 4 amps. And that has to be equal to what's going out of node A. What is going out of node A? And in means that the arrow is pointing inwards. Out means that the arrows are pointing outwards.
The 1 amp.
The 1 amp, just the 1 amp. So this is going out here. That's correct. But what is also going
the
out?
blue one, but I don't see the one that we have to find.
It's the one we're trying to find, and we call that IX. Okay. Now let's do the same thing for node B. Let's see what's happening in node B. In node B, now let's look at node B. What's going into node B? Can somebody tell me? Arrows are pointing inside. What's going into node B?
The 1A also, and
1 amp, correct.
And the one we're trying to find.
And IX.
And
what is
going
going out of node B?
4A.
4 amps. What do we notice here? These two expressions are equivalent, okay? Why? Because in the end, we have the conservation of energy. So if we're looking at one node and the other, it's going to be the same expression, just represented depending on the reference we're taking. So it's going to be the same equation. So from this equation, what is the value of Ix, which is the one we're looking for? What would be the value of Ix?
3 amps.
We have 3 amps. Okay. So the answer, no, no, and no, and the answer should be then 3. Okay. And that is correct. Okay. Was this clear? Questions with this one, or questions up to this point? No? Okay.
No questions, Professor.
Clear this up. Okay, let's see if we can finish this up before we go. The next one, this one is also very simple. According to the circuit we have here, the current that passes through the 6 ohm resistor is 4 amps. The current that passes through the branch with the 2 resistors is also 4 amps. What is the current that passes through resistor R1? We're going to do the same thing. Let's say that there's a node A here. I'm just going to use one node because there's a node A and a node B. We already saw that if the nodes are connected to the same branch, the equations are going to be the same. So if I say node A, and I'm going to say that the current I'm looking for that's going through R1, I'm going to call this one Ix also. How would the equation for node A look like? What are the currents that are going into node A?
The one we're looking for.
Ix, and what are the currents that are going out of node A?
2 sets of 4A amps.
It's 4 amps, correct, and 4 amps. Therefore, the current Ix that we're looking for is equal to
16 amps.
8 amps.
Man, I'm sorry. I multiplied. 8
Yeah.
amps.
4 and 4, 8. So if we look at the answers over here, it's going to be no, 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 and we should have 8 amps as the answer. Okay, let's see if that's true. 8 amps. Correct. Okay. So relatively simple. Let's jump to the next one. We're almost done. Same thing. For the circuit that's shown, there's a current in, there's a 4 amp current and a 6 amp current here. Now let's do something else. I'm going to take this node here just because the current is placed there. This is going to be node B. This is going to be node A. And they are equivalent. I'm going to now take node B. Do the same analysis in node A, it would be the same thing. But in node B. And we're looking for the current here in the 6 ohm resistor that I'm going to also call Ix. What is the current that's going, what currents are going into node B?
4 amps and Ix.
Okay, correct. 4 amps and Ix. And what is going out of node B?
6 amps.
6 amps. And so therefore Ix is going to be equal to 6 minus 4, 2 amps.
Professor,
Yes.
how do we know that the current is not crossing the 6 ohm resistor from right to left instead of from left to right?
Oh, going the other way around. That's actually a very good question.
Wait, it'll still be the same, right? Because it goes like left, up, right. Okay.
Yeah, if we would have put Ix the other way, what would happen is we would have gotten a minus 2 amp. And what does the minus mean? It means the arrow goes the other way. Remember, if the result is positive, it means that the arrow is going in the direction that, or the current is going in the direction of the arrow that I stated. If the result is negative, it means that the current is going the other way around. So if I were to have said that this current goes the other way, I could have done it for the circuit. It would have been 4 amps equals 6 amps plus IX, and I would have gotten a -2. What does the minus mean? It means it goes the other way around. So regardless of how you put the current, that's a good observation, JC. We could put the current however we want. The sign in the end of the calculation is going to tell us if it was correct or it's actually flipped. Okay. Was that clear, JC?
Yes, thank you.
And so we eliminate this one, and this one, and we are left with 2 amps. And that's correct. Okay, and let's just do the last one just so we finish this up. So very similar situation. We've got a circuit here. Let's use now, this one is node A, this one is node B. Let's use node A. And so in node A, and we're looking for the current that passes through so I'm gonna do something here on purpose. We're looking for the R1. I'm gonna say that the R1 is going this way. Okay, and I'm gonna call this IX. Okay. What are the currents that are going into node A? Can somebody tell me? What currents are going into node A?
None.
None, right? So it's 0. 0 amps. What are the currents that are going out of node A?
4 amps, 2 amps, and IX.
Amps, correct. Plus 2 amps. Plus IX. So what's going to happen here? IX is going to be equal to?
-6 amps.
-6 amps. What does the -6 amps mean? It means that IX isn't going this way. It means it's going this way. Okay. And so even though I set the current however I want, the sign is going to tell me if it's correct or if it's going the other way around. So the result, the mathematical result, it's not 8, it's not 4, it's not 2, it's, I think here on the bottom, it is 6 amps, which is this one here on the bottom. Okay. And that's that, okay? And again, the calculations are giving me the sign that we're using. The sign of the end result is going to give me if it was going correct or not. Okay. Questions with this one? Okay, good.